Hello, everyone. My name is Lifang. I will introduce. He asked me to stand here because I'm a little shorter. Okay. My name is Lifang. I will introduce our paper entitled "Joint Community and Structural Spinor Detection by Modularity, Harmonic Modularity." This work is cooperated with Lu Chengda, Ma Jiaqi, Cao Jianping, and Professor Shen Lingling and Philip Yu. I would like to specially thank Philip Yu because he brought all of these authors together. Okay. Here is the outline of this presentation. First, I will give our motivation of this paper. Currently, social network has becoming a hot topic in our life. It brings a lot of, it produce recently daily produce a lot of data set. We can use social network to do many things. It provides us $1 trillion opportunities. Social network is the fastest and largest growing real estate group around. Social network already becomes a bridge to connect our daily life and the vision of space. So social network analysis is the keyword for the 21st century. Here is the core research in social network. This is summarized by Professor Tang Jie. Yeah, in this paper, we focus on these two topics, community and structural. So what is the community? Community can be commonly understood to be a group of individuals more frequently interact with each other than with those outside the group. It is also well known as a group, cluster, cohesive subgroup, module in different contexts. Here is the example of the community. So what is structural spinor? Structural spinor, I need to first tell what is the structural. Structural means that when two separate clusters propose no redundant information, there is said to be a structure between them. Based on this, you can look at the left picture that the red person and the green person has no relationships, so we call that there is a structure between them. So based on this structural spinor, it means a node bridged across structural. That means a node bridged different communities. It will connect and consist this structural. Here the example like the right finger, the right picture. The red persons connect the data mining and database communities. So next, I will introduce our approach. First, I will give the key intuitions of this paper, which outcomes our method. Commonly, community structure reflects the level of harmonic of neighboring nodes. And the structural spinors behavior is characterizes the diversity of community of numbers nodes. So harmonic function offers a semantic way to cultivate the harmonic and the diversity of number nodes. Look at these formulations. In the intra-community node, we can usually use the harmonic function to compare the difference of the node and its numbers. That the difference between the node and its numbers in intra-community is equal to 0. But for the structural spinor, because its numbers connect to different communities, so the harmonic function is not equal to 0 between the structural spinor, its number, and its numbers. So based on this, we proposed the model harmonic modularity. And this is our objective function. F means community and the and the structural spanners indicator, it's just like the label indicator. And the objective function minor the harmonic level between the node and its neighbors. This is based on the harmonic function like this. So it is very direct to say this. Note, here we use the L2 norm to enforce the sparsity of F metric to discriminate relating the top key structural spanners. The L21 norm means the connection between the combination of L1 norm and L2 norm. It will enforce the matrix, each row of matrix into nearly zero sparsity. Based on this, because if a node belongs to the same community, the difference of this node and its neighbors will equal to zero, just because it equals to harmonic function. But for the structural spanners, its neighbors holds in different communities. So this the difference of these these nodes didn't equal to zero. We will use the L21 norm to penalize these values, and so we minimum this objective function to get a harmonic result for these different nodes. Here is our algorithm. After once we get the F metric function metric indicator, we can get the community and the structural spanners. To get the structural spanners, we can sort each node according to the value of each row in antecedent order and select the top key structural top key ranked ones and structural spanners. After this, we can remove the detected structural spanners and then cluster F metric to use the k-means to get the clustering result. Usually, after we detect the structural spanners, currently there is no method that can decide which the identified structural spanner is good or not. So how to decide this? To evaluate this identified structural spanners, we proposed a metric called structural influence index. The structural influence is a metric based on the information influence to measure the performance of structural spanners. Note, here we need to see, first we need to see the nominator. It measures the number of influenced outsiders given a selected structural spanners. If we use this as the seed of some information diffusion models, and we spread the information from this identified structural spanner, we can count how many outsiders are infected from this structural spanner. So the numerator means how many nodes are influenced by this structural spanner, or they received the information from this structural spanner. The denominator is very important because some nodes located in the central community, in the center of some communities. If this, because it has a high degree, so it will also very quickly diffuse the information. If we count both the inside and outside node, we can discriminate which is the high degree node, or which is the central node, and which is the structural spanners. So this is our proposed metric to measure the identified structural spanners. Especially this model depends on the applied information diffusion model to diffuse the information. Finally, I will talk about our experiments. Here is the data sets we used. We used 3 data sets, including Carrot Club, DBLP, and YouTube. The detail is shown in this table. Our goal is community detection and structure house binary detection. So our baseline is focused on both of these. In the structure house binaries detection method, currently there are some unsupervised method, and the bottom 2 are supervised method proposed by Professor Tang Jie. And the community detection, we use spatial method and modularity method, which is a popular community detection method. First, we will first focus on the structure house binary detection, because structure house binary detection will affect the community detection, and it will also benefit to community detection. Here is a case study on the Carrot Club network. The visualization can be seen that we found the top 3 structure nodes. Compared with other methods, we can see that our proposed method catches the most intermediate nodes between communities. But for other methods, it tends to take the highest degree nodes and the structure house binaries. So this is the difference between our method and the compared method. Here is the structure house binary detection results. That our method is always better than other compared methods. Okay. We use the IoT model and IC information diffusion model to test this experiment. Here is the community detection method. Yeah, in the left column, we compare the different community detection methods on the whole network. Since our method only can detect the intra-communities node, so after we remove the structure house binaries, we will use the maximum voting to get the label of structure house binaries. In this way, we can make a fair comparison about our method and the compared method. We can get, it can be seen that we can get the better result for this. The right column means that after we removed our method identified the structure house binaries, we will use other compared method to detect the community. It can be found, compare the left column and the right column, it can be found that the performance always improved after removed the identified structure house binaries. So this is the community detection. Also, we show that our method is very efficient to converge. It can be seen that our method only takes 20 iterations on these 3 data sets. In this figure, x-axis means the number of iterative, y-axis represents the objective function value. It also can see our method will decrease nearly to 0. So this is why we call our method harmonic modularity. Yeah, because after we identify the structure house binary, the objective function will enforce the structure house binary into 0, and then it will show the harmonic function. Yeah, in this method. So here I will give the conclusions of this paper. In this paper, we proposed a joint study method to study community detection and structure house binary detection together. And first, we proposed a harmonic modularity method to study these 2 problems. And then we also provide a metric to measure how the performance of this identified structure house binary good or bad. So our methodology provides an innovative perspective on the analysis of structure of network structure. That's it. Thank you.
Well, there are questions being thought of. I have a question. So there are several methods that directly use flow and diffusion in network to identify communities, and essentially they're flow-based community identification methods, and some even use implicit community, so the flow to identify implicit community without the network information itself. So this seems to be very similar in spirit to the way you're looking at the structure of communities. Have you considered sort of what's the comparison between the two? How do they differ both sort of conceptually and in the results?
So you mean that I need to compare the communities and the identifying the structural spanner?
Right, so there are methods that use flow, which is what you're using to identify the spanners, the structural holes, right? And to measure the similarity within and across, they use that measured directly to identify communities.
I say we didn't try this experiment, but we will try
this
later.
Please use in the microphone. Maybe.
Okay.
Yeah, okay.
Yeah, we didn't try this, but we can also use the conversion method to measure this identified structural spanners. Conversion structural spanner identify method. Oh, okay. Although there are some conversion identified structural spanner measurement to evaluate this performance, but they didn't consider the community detection, the community structure. Our proposed identified structure, our proposed metric considered both the community and the community structure and the information flow from this identified structural spanner. So this is the difference between our measurement, our metric and the traditional method. Yeah.
Okay, so what algorithm do you use to solve the optimization problem you mentioned?
Oh, this problem can be solved in eigenvector problem.
So is this some STP kind of thing?
SVD.
SDP.
Oh, STP.
SDP.
SDGLP. What's the full name of STP?
Semi-definite program.
Oh, I didn't know this method.
Okay, never mind. We can discuss.
Okay. STP.
Any other questions? Just thank the speaker.
Okay, thank you.